Hello everyone, welcome to my channel. Myself Sonali Gupta, and this video is about the internal reflection, that means total internal reflection. See here, we are moving rays. Here light rays are enter from denser to rare medium. Here we are, when light rays travel from denser to rare medium, that rays partially reflected and partially refracted. That means, see here, these are two medium, denser and rare medium. When this is our object, when light rays enter, this is our incident angle. When light rays moves from denser to rare, then partially rays is refracted and partial rays is reflected. This one our partially reflected ray. This is our partially reflected ray. This is our refracted ray. Again, when light rays moves from denser to rare, then this refracted rays always moves away from the normal. This ray is moved away from the normal. Again, when this is our incident angle. This is our incident angle. This is our refracted angle. Again, and this is partially reflected ray. In this case, light rays moves from denser to rare medium. Here two mediums, denser and rare. When light rays moves from denser to rare, this ray, incident ray, is partially reflected and partially refracted. That some part of the rays is refracted and some part is reflected. Again, and this refracted ray is moves away from the normal. Again, when we increase the incident angle, when we increase this incident angle, then this refracted ray move again away from the normal. That ray is moving away from the normal. That means this incident angle increases, so this refracted angle also increases. Again, in third case, if we increases again this incident angle is again increases. At this time, what happened, this incident angle, this refracted ray is move away from the normal in such a way that this ray is moves this along the surface of that medium. Means this ray is moves this is our, in first case this is refracted ray, second this is refracted ray. Again we increases, then this refracted ray is along the surface of these two medium parallel to the, that means this angle of refraction is 90 degree. This angle of refraction is 90 degree, and this happened at incident angle. That incident angle is known as critical angle. That incident angle is known as critical angle. This condition at which this incident angle, at which angle of refraction it become 90 degree, that angle, that incident angle is known as critical angle. That means this critical angle, at this critical angle, this refracted ray is parallel to the surface of these two medium, and that means this angle is become 90 degree. After that, when again we increase incident angle is greater than critical angle, when we increase this incident angle is greater than critical angle, then what happened, there is no refraction, there is only reflection. This ray is totally reflected. That means at the angle, if the incident angle is greater than critical angle, then at that point there is no refraction occur, and at this point only reflection takes place. That ray is totally internally reflected. This is our reflected ray. And this condition is known as total internal reflection. This is known as total internal reflection. Here this ray, this incident ray is totally reflected. Here refracted ray does not occur, refraction not occur, only reflection occur, and this ray is totally reflected in same medium. That phenomena, this condition is known as total internal reflection. See, okay, what what happened here, क्या हो रहा है, देखो, we know that refraction and reflection. Refraction here, इन वी आर मूविंग लाइट रेज फ्रॉम डेंसर टू रेयर. हम डेंसर से रेयर में जब लाइट रेज ट्रैवल होती है तब क्या होता है, पार्शियल रे रिफ्लेक्ट होता है, पार्शियली रे रिफ्रैक्ट होता है, दोनों ही फिनोमिना हो रहे हैं. उस रे में से पार्शियली रे रिफ्लेक्ट हो रही है एंड पार्शियल पार्ट ऑफ दैट इंसिडेंट रे इट बिकम रिफ्लेक्टेड. But refraction is occur always away from the normal because this ray moves from denser to rare. This ray moves from denser to rare, so always refracted ray is moving away from the normal. हमेशा क्या होगा, refracted ray normal से दूर जाएगी because here light ray travels from denser to rare. What happen here, in first condition this incident angle is less. हमने क्या किया, यहाँ 4 कंडीशन है. फर्स्ट कंडीशन में इंसिडेंट एंगल हमारा बहुत कम है, then we increase that incident angle. When we increase incident angle, then this refracted ray move more toward away from the normal. Means ये reflected ray normal से और भी दूर जाएगी. इस केस में भी दूर जा रही थी बट सेकेंड केस में वो और ज़्यादा दूर जाएगी. थर्ड केस में क्या हुआ, थर्ड केस में इस इंसिडेंट एंगल पे दिस रिफ्रैक्टेड रे इज पैरेलल टू द सरफेस ऑफ दिस टू मीडियम. ये रे आपके इस सरफेस को अलोंग इस सरफेस में आ जाएगी और वो एंगल ऑफ रिफ्रैक्शन इट मेक्स 90 डिग्री एंड दिस इंसिडेंट एंगल इज नोन एज क्रिटिकल एंगल. जिस एंगल पर ये होगा, जिस एंगल पे एंगल ऑफ रिफ्रैक्शन 90 डिग्री होगा, दैट एंगल इज बिकम क्रिटिकल एंगल. And after that critical angle, if that incident angle if greater than critical angle, in that case what happened, in that case there is no refraction occur, there is only reflection. That means this incident ray is totally internally reflected and that is this is reflected. Here there is no refraction occur, only reflection take place and this ray is totally internally reflected, so it's known as total internal reflection. This phenomena is known as total internal reflection. In this TIR, total internal reflection, two conditions. Here we require two conditions. That conditions are, first, light ray must be moves from denser to rare. मीन्स अगर लाइट रे डेंसर से रेयर में मूव होगी तो ही ये टोटल इंटरनल रिफ्लेक्शन होगा, अदरवाइज नहीं होगा. दिस इज द फर्स्ट केस. दैट मीन्स when light rays moves from denser to rare, then and second case is incident angle must be greater than critical angle. मीन्स अगर इंसिडेंट एंगल क्रिटिकल एंगल से बड़ा होगा तो ही क्या होगा, दैट रे इज बिकम टोटली इंटरनली रिफ्लेक्टेड. This phenomena is known as total internal reflection. Here two conditions must be satisfied with TIR. When two conditions are satisfied, then there is the total internal reflection occur. First condition is that light ray must be moved from denser to rare and second is that incident angle must be greater than critical angle. What is critical angle? See, critical angle is that incident angle where this angle of refraction is become 90 degree. Where angle of refraction is become 90 degree, that incident angle is known as critical angle. And after that critical angle, if angle of incident is greater than critical angle, then this total internal reflection occur. So this is the phenomena of total internal reflection. See, again critical angle, we calculate the value of this critical angle. See, here this is our denser medium, this is our rare medium. Here what happen, when light ray, this is our normal, with light rays incident, then that ray, refracted ray, it become 90 degree. This is our incident ray. So this is our mu2, this is our mu1. Okay, apply Snell's law. According to Snell's law, what happened, हम क्या कर रहे हैं, हम कैलकुलेट करेंगे क्रिटिकल एंगल की वैल्यू. सो व्हाट फॉर क्रिटिकल एंगल, व्हाट हैपन, एंगल ऑफ रिफ्रैक्शन इट बिकम 90 डिग्री. टू मीडियम, डेंसर एंड रेयर. डेंसर मीडियम become mu1 and rare medium mu2. What happened for Snell's law? This is our first case. So mu1 sin I is equal to mu2 sin R. This is incident and this is reverse, first and second. This is our Snell's law. हमने स्टडी किया है स्नेल्स लॉ, हमने यहाँ पे सिर्फ स्नेल्स लॉ को अप्लाई किया है. हमने दो मीडियम लिए, mu1 एंड mu2. हियर एंगल ऑफ रिफ्रैक्शन बिकम 90 डिग्री बिकॉज दिस एंगल इज क्रिटिकल एंगल. ओके, सो हियर व्हाट हैपेंड, mu1 sin I, replace I with critical angle because here I is become C and R is 90 degree. So here mu2 sin 90. So mu1 sin C is equal to mu2 sin 90 degrees 1. So what happened, sin C is equal to mu2 upon mu1. mu2 upon mu1. This is the value of critical angle. Sin C is equal to mu2 upon mu1. Again here, see, if rare medium is air, that means rare medium is air, so mu2 is equal to 1. Okay, then what happened, if our rare medium is air, then mu2 is equal to 1. So sin C is equal to 1 upon mu1. And mu is our denser medium. mu क्या है हमारा, mu1 है denser medium. Denser medium का refractive index. This is the refractive index of denser medium. mu1 is the refractive index of denser medium and mu2 is the refractive index of rare medium. So this is the value of your critical angle. For critical angle क्या करना है हमको, कुछ नहीं. हमने यहाँ पे क्या किया है, इंसिडेंट एंगल को C लिया है क्रिटिकल एंगल एंड एंगल ऑफ रिफ्रैक्शन इट बिकम 90 डिग्री बिकॉज दिस इज द कंडीशन ऑफ क्रिटिकल एंगल. दैट मीन्स इफ द इंसिडेंट एंगल इज क्रिटिकल एंगल देन angle of refraction it become 90 degree. So here applying Snell's law, what happened, mu1 sin I upon is equal to mu2 sin R. Here we are substituting values. I is become critical angle and R is 90 degree. So we get sin C is equal to mu2 upon mu1. Again here, if mu2 is the rare medium, that means if air, so its refractive index is 1. So we get sin C is equal to 1 upon mu1 and mu1 is the denser medium, refractive index of denser medium. This is the refractive index of denser medium. Denser medium कोई भी हो सकता है, एयर के अलावा ग्लास है, वाटर है, different denser medium, and for that denser medium we can calculate the critical angle. So this is the derivation of critical angle. So this is all about the total internal reflection. So if you like it, please subscribe my channel. Thank you.